Imagine someone sitting in front of you. Can you see this line comfortably for 3 hours? Because I can raise a tiny bit more if you want. Who wants it raised a little bit more? Okay. So how's that? Can you see that last line? Okay, sorry, I'm done my fiddling. I've tried a number of times to figure out how to make that faster, but haven't figured out how. I'm going to start in about 2 minutes, so this is discussion that's not for the video audience. I asked some questions of individuals who were here a little bit earlier when I arrived to get some idea of background. That'll help me target you as an audience in terms of setting the right level of stuff. Make sure you have the exercises downloaded. I have not yet seen the survey link. That person with the sheet who's taking attendance. Do you have the link for the survey?
I do indeed.
Perfect. And let me give you that link. Where did I put that thing? HBL3K3S. Oh, that's not right. There's the survey link. So I encourage you to fill out that survey towards the end of this tutorial or after. I'll send you the link in an email as well if I remember. It's really helpful to help me make this tutorial better for people who take it in the future. The reason it's as good as it is right now is it used to be not as good. Now it's this good because other people in the past have given me feedback. How many of you have used Python for more than a year? Good. Mostly not. How many of you have used another real programming language, like Perl or Java or C or et cetera? Raise your hands. Any of those? Anything you would consider a real programming language, general purpose programming language? How many of you have not used any general purpose programming language, but have only used maybe SAS or R or, okay. The programming languages that you have used other than Python, throw your hand up if it's C, C++, Java, Perl, Ruby, PHP, any others? Well, not with a lot of hands, whoever they are, because I think most of you already got a hand up. Okay, that's all helpful to me. So if everyone's got the exercises downloaded and has, for the exercises, you'll need the Python interpreter read eval print loop open. And you can just, I will be typing stuff, or actually telling my computer to type stuff for me, and you will be doing the same for the exercises. The rhythm is I'll do some talking, and then I'll do some exercises. Okay, so I'm going to get ready to actually start the tutorial officially here, which probably should be the start of the video. Okay, any questions before we get started? Great. Welcome to the Python by Immersion tutorial here at PyCon 2018. Thanks everyone for coming. I have been doing this tutorial in various formats in various places for almost a decade. This is actually my 11th time teaching some kind of tutorial at PyCon. Taught computer science at university for a while, so I've got a fair amount of teaching experience in sort of scattered areas. So hopefully this will work. If it doesn't, I certainly want to hear feedback on the survey link or just in person because it helps the tutorial get better. So you're going to be drinking from a fire hose. So I'm going to show you about 1,100 lines of code in under 3 hours and talk about a fair number of them, especially early on, somewhat slowly, and then we'll get faster. Please try not to get discouraged if you don't understand everything I go over. I think you'll understand most of it, but some stuff you won't, and that's okay. Definitely do not try to memorize what I'm showing you, right? So the title of the tutorial, Python by Immersion, is like learning a language by immersion, right? You don't start with, well, here's the grammar, and here are the tenses of the verbs, and here are the, those kinds of things. Instead, it's just like you just start listening, and you start absorbing. Your brain starts absorbing in ways you don't even understand. And that's my goal here. So I'm going to show you a broad overview of the language. And my hope is 3 weeks from now, when you find yourself needing to do a particular thing in Python, you'll be able to say with some level of confidence, but you're not sure why, oh yeah, I'm pretty sure I can do that in Python pretty easily. Even if you don't remember what I showed you today, somewhere in your brain will be the knowledge that you have a sense for what Python's about, and you have a sense for the kinds of stuff you can go looking for. Okay? I'm going to start the first 20 minutes about fairly slow and a little bit pedantic, trying to explain certain things about Python that are very different from many other programming languages, especially a number of the ones that you are coming from. And that all has to do with objects and names and variables. Yeah. So, and the rhythm is that I will talk for a bit and show you some code, and then I'll give you time to work on some exercises, during which time I'll wander around. And if I answer questions when I'm wandering around, I'll probably just answer them one-on-one and then summarize them at the end when I come back up here, and we'll go through the same exercise you just did, but a little bit quicker and adding the explanations, especially where people had questions. Feel free to stop me with questions, raise your hand. Sometimes I'll say, ask me later, or I'll get to it later. Sometimes I'll answer it right then. Okay, any questions before we get going? Okay. So here's the form of this tutorial that this is what most of it's going to be like. I'm going to show you lines of code and talk about what's going on. First of all, I'll tell you what version I happen to be running. And then I'm going to talk about how objects get created in Python. And this will be kind of slow, but it's really important to understand and get the right mental model of how this works. So I'm going to talk about this line for about 2 minutes. I'm going to type the number 1 and hit enter. So this is the read eval print loop. You can tell that by the 3 little greater than signs or the chevron there. At the read eval print loop, when you type an expression, Python parses it, compiles it into bytecode, not into machine code, but into bytecode. It then executes it, and if it's got a value, if that expression has a value other than none, it will display that value on standard output. So it'll print the value of the expression. Okay? So there, it just did it. It evaluated the character, which is the digit 1, and it figured out that that's an integer literal, it's called, because you literally are typing the integer into the prompt there. And you can put all these lines in code, too. The only difference between the read eval print loop, the REPL, and what happens when you run your code is it doesn't automatically print out all the expressions. The read eval print loop prints the one. If you write a script or code, it's not going to print the one unless you use the print function. But what actually happens when I type the 3.14 in this example? By the way, the numbers on the far right, those are just line numbers to keep me on track, and I can go back quickly. So when Python sees a literal like this one's a floating point literal, it creates an object which represents the literal. So let's go back to the 1 there and just do that one because that's what I'm used to talking about. So when I type the 1 and hit enter, Python goes off and it creates an object in memory. An integer on most of your machines takes about 64 bits of memory, about 8 bytes. The object that Python creates is more like 30 or 40 bytes big. It's huge in computer terms relative to the amount of memory that's actually stored in the integer. So you got this big object that has all sorts of information in it, of which the 1 is a small piece. The other stuff is what type it is, what its superclasses are, what its documentation, there's a whole bunch of stuff in there, how many names are bound to it, etc. Okay, so every time you do that. So this is in contrast to the way you're used to thinking about variables in Python and any language. Most people think of variables as a box within memory, a location in memory, and if I assign a variable the number 3, I write over the bits that are in that box with new bits, and I get the 3 in there. And if I say that variable equals 17, then I erase those bits and write over it with 17. That's not what's happening in Python. In Python, if I say I equals 1, it creates an object and makes I refer to it. If I say I equals 17, it creates a different object and makes I refer to that instead. And I'll repeat that a few times in the next section as well. But let's just look at how you create stuff in Python. So I can create integer literals, floating point literals, string literals with single quotes or double quotes, round brackets or parentheses around a list of literals or a list of anything, a sequence of anything, gives me a tuple, sometimes pronounced tuple, and it's an immutable list is a good way to think about it. If you put square brackets instead of round brackets, it's almost the same, except it's mutable. So 1 you can change easily, 1 you can never change. Once you've created a tuple, you can't pull things out, you can't change elements in it. A list, you can change it all you want. And there's some reasons for why there are both that aren't that important that I'm not going to really mention. Hang on a second. Oh, sorry, wrong code. Okay. Great, all that work and now. Hold on a second here. Okay, so when you create objects in Python, they have a single value, a single type, they have attributes, they have one or more base classes. If you understand what classes are, it's not going to slow you down much today. Every object has a single ID, and every object has a name, usually. Almost all objects have a name, and many times objects have more than one name. Those names live in different namespaces. So I might have 2 names in my current namespace, and I'll explain what namespaces are soon. You might have more than one name in the same namespace. Much more often, you'll have names in different namespaces, like you might import a module and then access an attribute of it. And you might have names in multiple places. So let's, sorry. Right, I'll get the hang of this soon. Okay, so let's explore this a little bit. So what's going to happen here is one of about 10 times. I'm going to slow down and just say it the same way. Python sees the 1, it creates an object. It sends that object, it then looks up the name type and finds another object, which happens to be a function, a callable. Type is a class or a function, but it's callable like a function is. It then takes that object and sends it off to that other object and executes it because it's got the round brackets. It does a call. It executes that function. That function does something with it and returns a new object, which is the class int. The class of which 1 is an instance is its own object. So classes are objects in Python. Everything in Python is an object. And then it tries to represent that class. Well, instead of showing you the C code that implemented it or the Python code that implemented it, it says, well, it's a class and it's got its name int because it's trying to show you what it is, but it's hard to show what it is because you can't type this back into the prompt and get the class int. Okay, 3.14 is type float. There's string for a string, str. The type of that tuple is tuple. There's the list. Objects have attributes. So this looks up the name true, finds an object, and then tries to access dunder doc. So this is a double underscore doc, double underscore, which we say instead of saying double underscore true double underscore, we say, or sorry, doc, we say dunder doc. So if you hear me say dunder doc, it means double underscore on both sides. And those are attributes in Python that are sort of behind the scenes. You're welcome to use them, but they're sort of more implementation side than user side. And you can see that that has an attribute, which is this long string that explains how doc works. Here's a string object, and we access its upper attribute, and we get back built-in method upper blah, blah, blah. So it's a method. Methods are like functions, but instead of calling them with parameters or arguments, you call them on an object and pass extra arguments. So a method is always a call made on or to an object. So this method, when you call it, operates on that, okay? And when I say operates, doesn't mean it actually necessarily changes it. It might just return a new one or a different version or how big it is, right? So here I'm going to check, is that string, is this attribute of this object callable? Yes, it is. So I can call it like a function. So I will call it like a function. Here I just access the attribute. Now I'm going to call it like a function. And it's like I'm asking the spam object, give me an uppercase version of yourself. And so it returns a new object, which is an uppercase string spam. Okay? Objects have base classes. The inspect module is a good way to look at them. So spam is an instance of string, which is a subclass of object. True is of type bool, which is a subclass of int, which is a subclass of object. So if you're familiar with classes, everything in Python, the superclass of all the objects in Python is the type object, which just has a few rudimentary things that it can do. Every object in Python has an ID. The ID of the object that gets created when Python sees the 3 and creates that integer object that represents the 3 with some long number. The only thing you're guaranteed is that number's unique across, between, like every object has unique ID. Other than that, you don't need to worry about what that means. And so here, in CPython, which is the version, the implementation of Python most people run, it's written in C, that's why it's called CPython. It's actually a memory address, which is kind of interesting. But that's not guaranteed to always be true, and it's not true in all implementations of Python. Here's the other way to create objects. So far, all I've done is directly created objects with literals or called functions to get them back. In general, you usually call other objects to create object or get access to objects. So abs is a built-in function. It is callable. If I pass it this object, I'm going to get back a different object in this case. All right. Int is a built-in type. 3 was an instance of int. It's actually callable. And every class is callable because when you instantiate a class, you do it like a function call. In this case, it kind of functions, int sort of feels like a function that when you call it, converts whatever you pass it to an int. Like that. Okay, so let's talk about names more carefully. I just restarted my Python to clear my namespace, which makes things a little easier. So there's built-ins, which is a name that shows up in my namespace in the way I'm running Python here. Let me create a little function here that you don't need to worry about how that works. When I say a equals 300, I'm going to add this name to my current namespace, and I'm going to take that object that got created when the 300 was interpreted and make a reference to it. So if you want to say a is a variable and it holds the value 300, mathematically that's good language. In terms of computer programming, it's a little bit misleading, especially if you don't have the right mental model for how it works. And even if you've only ever learned Python, people talk about variables this way. They talk about the box into which you put values. So I prefer, at least when I'm teaching, to use the language that's standard in the Python documentation, which is the name A is bound to the object 300. So this is a name binding, and the name lives in a namespace. Okay? Once you've bound the name A to the 300, then you can see, in my namespace, I didn't have anything before. Now I have a name A. There's a representation of the object's, what it looks like, and here's where it actually lives in memory, its ID. So Now I can type A and hit enter, and Python says, oh, that looks like a string, but it doesn't have the quotes around it. But it's a valid identifier. It starts with a letter, uppercase or lowercase. It has some number of letters, uppercase or lowercase, or maybe an underscore in it with no breaks. Therefore, that looks like an identifier. I'm going to assume it's a name. I'm going to look it up and try to find it. If it does, it gets the object back and tries to show it to you. That's why you get the 300. Okay? I'm not going to go this slow the whole time, don't worry. But thinking about it this way is really important, so that's why I'm taking the time now. All right? So, I actually had a mistake here that I didn't notice, which is I forgot to do this. So, I've restarted the interpreter. The namespace was cleared. If I type A now, it's going to go look in the namespace because it looks like an identifier. It's not going to find it. Really, I thought I restarted the interpreter. There we go. Now if I type A and hit enter, I get a name error. Okay? So if you type a name and it's not in the namespace, it can't find it, then it gives you an error. Well, but how did it find abs and true? Well, that's different. Those are sort of built-ins that are hiding behind the namespace. So this is the error you get, name error. And when you see errors like this, read them. The first 10 of them, you're like, this is kind of complicated. What does this all mean? But once you get in the habit of reading errors, they actually come in really handy sometimes. Often, you'll find that if you read the error after reading 10 or 20 of them, you get to the point where, oh, actually that does give me a clue to what I did wrong. So in this case, traceback, if this were a function calling a function calling a function, you'd have that whole call stack in the traceback. In here, it's a single line because I'm running at the interactive prompt, the REPL. And it's saying, and it was running this file. Well, it's not a file, it's the REPL, so it calls the file console. It's at line 1. Well, obviously, there was only one line. And it wasn't in a module because I was just running at the REPL. But then it gives the error. So name error is the name of the exception. This is a common name. It's usually uppercase, lowercase, camel case, and it's name error, something error, something error. And then it tells you exactly what it was. Name A is not defined. Okay, so a little diversion there about reading names. Okay, so let's go back and we got the A, and there's the 300. Okay, so I've got that. I can access it. And what if I type A equals 400? So what's going to happen is Python sees the 400, goes off and creates an integer object representing the integer 400. It then says, okay, I'm going to add this to the namespace. Well, actually, it's already in the namespace, so it's just going to change the value. So namespaces in Python are like dictionaries. Dictionaries are mappings from keys to values, and it's a common data structure in Python that we'll explore later. Key-value pairs. So the key is A, the value is 400. In a dictionary, you have to name the dictionary, use square brackets, put a quote around the A, close quotes, square bracket. Names, it sort of does all that for you, is another way to think about it. It's like a dictionary that it doesn't, you just type the characters right away and it assumes you mean a key in that namespace dictionary. Okay, so here it's just going to change the value that's already in the dictionary for the name A in the namespace. Right? So we can see that the namespace changed. The A is still there, but different value, different location. So what this does is it looks up the name A, gets back an object, and then adds a new name to the namespace B, which refers to that same object. Okay? So it's not copying the value from A to B in the traditional variable computer science or computer programming sense. It's just putting two names in the namespace that point to the same object. Okay? And if I look at B, it says 400, A is 400, and you can see that they are at the same address. So these are actually the same 400 because it's one object that represents the 400, two names. The other way to think about names as being bound to objects is to think about post-its, right? So if I have a post-it and I write Stuart on it, put it right there, that's a name for me, is Stuart. If I write Dad and put it on a post-it, stick it on me, well, in some namespace at home with my kids, that name is the name for me, right? In a different namespace, someone else's family, when you put the name Mom on you, you're gonna, if you're a mother, then your kids will understand that name. But in our family, it's like a different namespace. Mom means a different thing. It's bound to a different object, okay? So think of post-its on an object, and you can have multiple ones, just like we have an A and a B here. C equals 400? Oh, okay, so interesting. Now we have A and B, they all have the same value. These two actually are at the same address, so we know those are the same object. This one's at a different address. That's up to Python whether or not it creates the integers at the same address or different, and it actually pre-allocates some. Sometimes it'll reuse an object, sometimes it won't. In the case of integers and strings, it can reuse them because they're immutable. You can't change the value of one. It's always one. So this is getting sort of, so I'm going slow to explain names and namespaces and objects. I'm also showing you some of these behind the scene details, like where the memory is, just because that helps you understand what's going on at that level, right? So if you want to program well in Python, it helps to know a little bit about what's going on underneath the hood or behind the curtain. If you want to know how to drive a car really well, it helps to know a little bit about the engine works. If you want to ride a bike really well, et cetera. So knowing the next layer down, a little bit of it is helpful, I think. So IDA is the way you can get these addresses. Is the way you check in Python if I'm going to say it wrong, if two objects are the same. Well, if two objects are the same, they are the same object. So what it really is checking is if the name A is bound to the same object as the name B. Are those two names the names for the same object? That's what is means. It does not mean really, really equal. Right? Some languages you've got equal, double equal, triple equal. That's not what it means. And there are some edge cases where you'll actually get in trouble if you assume that is the same as equal. Yes, question? Yep. Wonder if I do that next. No, I don't. Well, now it's going to fail. Let me just show you. Oh, sorry, it's gone. The answer is yes, it would, sorry. So A is B was true. It's now false because I went on and moved backwards. And if you said A is C, you would get the answer false. So here I'm going to change A to be ABC. Well, you can talk like that. Remember, what we're actually doing is we're creating a new object representing the string ABC and binding A that was looking at the 400. I'm binding it to now refer to the string ABC. So I'm rebinding the name. All right. So now if I look, B is still 400. Show names shows me I've got A is bound to that, B is bound to that, C is bound to that. These are two different objects. Usually you don't need to worry about this, but when you do need to worry about it, you really need to understand it. And it really matters a lot in rare cases, well, relatively rare. In some of you are doing pandas, for example. There are cases where whether or not the objects are the same object or if they're just equal makes a big difference in terms of performance. Sometimes you just want to use the same one again because to reallocate a data frame with millions of rows is going to be inefficient. Okay, we're almost past the slow, boring name stuff here. Del A, what do you think that does? It takes the post-it off and throws it away. It doesn't take all the post-its off, just the one that was the A. It doesn't do anything with the object. The object is not deleted when you call del A, right? When is an object deleted? Well, when all the names, when all the post-its have been pulled off the object and there's no more references to it, then there's no way it can be reached from any line of code. Then Python goes and cleans it up, and that's called garbage collection. And that's very convenient for programmers to not have to worry about that. In languages where you do have to worry about that, memory leaks are always a problem unless you're very careful, or there's strong language support for it. So now we've just got B and C left. A is gone, del B, del C. Now it's empty, nothing in the namespace. I said there are cases where knowing when you mean equality and when you mean is. Basically, the only time you want to use is in common practice is in a function when you're checking to see if a non-default parameter was passed or argument was passed, and I'll show you that later. And so you'll often see at the beginning of a function, if arg1 is none, well, that's the right thing to do. Otherwise, you almost always want to use equality instead of is. And here's proof. Okay, that's interesting. So I said I equal 10, j equal 10. Turns out that when Python saw this 10, it didn't go create a new object. It went and found the one that already existed that represents the integer 10. And so you can see, here I'm going to, the comma here means please evaluate these expressions. It's actually an implied tuple. I'm saying, are they equal? Are they the same name? Are they two names for the same object? Yes and yes. And you can see they're at the same address. However, in here, I equal j equals 500. This is Python syntax that says, please bind both these names to that object at the same time, or right after each other. So it's actually, here you're guaranteed that whatever j was bound to, I is going to get bound to the same object. And you can see that they're equal and they're the same object. Yeah. But this one does not. So in this case, if I say to Python, I want to use the integer 500, it goes and creates a new one. And you say it again, it goes and creates a different new one in a different location. And so these are equal, but they are not two names for the same object. They are two names for two different objects. And why it does it this way, it's for efficiency reasons. Integers from about -5 to +256 are commonly used, and so pre-allocating them saves memory. Whereas other integers aren't used that often, so it doesn't pre-allocate them. So that's behind the scenes what's going on. The lesson here is use equals almost always when you want to check for equality. Use is extremely rarely. Okay. So import math, what it does is it asks Python to go find the library named math, pull it into memory so that it can actually execute parts of it, and then puts the name math in the current namespace. So it bound the name math to that module. Now I can access the attribute of that object. Like math is name referring to an object. It has an attribute called nan, and if I get that back, it shows me as nan. Some of you are familiar with this. It's not a number. It's a representation of something that's not a number. Its type is float. So here's a counterexample that's kind of weird. In this case, they are the same object, but they are not equal to each other, right? And that's just the weirdness of nan, and it's useful to have that behavior. So the nan object is not equal to itself, but it is the same object, okay? Just driving home the point here, use equal, equal. Okay, so now I'm going to let you do some exercises. This section, can't remember exactly how long it is, I'll bring it up and see for myself. So I'll give you a few minutes to do the exercises. When you do the exercises, I encourage you to, I've tried to make them easy to type, so a lot of times I use short names and short stuff whenever possible. I encourage you not just to type them and hit enter. I encourage you to type it and then think about what's going to happen here, right? Oh, okay, it says, for example, it says, okay, like here, when you type this into the interactive prompt, type I before you hit enter, figure out what's going to happen. What is going to happen when you hit enter on this? Okay, and if you can't figure it out, that's okay, go ahead and do it, but try to figure it out ahead of time. And I will wander around and answer questions, and then we'll move on. Usually when about half the class has done the exercises, I make them long enough and hard enough near the end that I try to keep everybody happily doing exercises, but when you're about halfway through, you've gotten as much as you really need to know to move on. Any questions? Okay. So if you haven't gotten the exercises yet, they're second to the bottom line here. HTTP bit.ly PyCon 28-immersion, or it was emailed out to you about 3 hours ago as well. It'll bring up a Dropbox screen that shows 3 files. You can download one of them or just click download and download the whole zip. dir is what you should use to show what the names are in combinations.
Could you also just use locals?
Yeah. But you can't use locals when I use dir, the other form, which is to pass it an object. So.
Where do we stop?
Stop at the end of the exercises. Is that clear? It's like, let me just. So when you get to the numbers, we haven't talked with numbers. You did a little bit with lists. Okay, so how many people are done? Lots of people. Like, when you're half done, when half of you are done, that's when I want to move on in general. Don't feel bad if you're not finishing as fast as everyone else. This is normal. Like, different people are here with different levels. I usually will move on before everyone's finished at all. Learn what you can, and you can go through some of the stuff again later, watch the video again later, etc. Okay, so now I'm going to go through the exercises, which means even those of you who didn't finish, you're going to see me doing them and show you what new things there are to learn and answer questions you might have as you're going.
Can you unmute your mic?
Thank you. Okay, so I'm going to now go through the exercises that you just did, and those of you who didn't finish, you won't have to worry about not finishing because you're going to see what I'm doing. So, name error. How many predicted that correctly? Oh, that's pretty good. More than half didn't, and that's normal. You don't. I'm making you think. I'm going to intentionally frustrate you a little bit to make you think, and hope that doesn't go overboard. Because thinking about what the computer is going to do is a really effective way, especially when you're diagnosing a problem. Just look at the code and say, okay, what's Python going to do in this situation? It's a really effective way to find bugs and figure out why something's not doing what you think it should be doing. Because Python can't read your mind. And you can see there is no I in the namespace. Once I bound I to the object, integer 1, then when I type I don't get a name error, I get the value back. And you can see that the I got added to the namespace. It's an int. Now J and I are two names that are bound to the same object. And I know that not because of the value, but because J equals I, it's going to bind J to the same object that I is bound to. That's not implementation specific, that's guaranteed by Python. And so they are going to be the same, two names for the same object. So this is a list we create here with two names. And those two names, the object is the same, so it looks the same. You can see the M and the N names that got put into the namespace. You didn't do the restart like I did, so you'll probably have I in there as well, and maybe some other names. This is the syntax in Python to access element at index 1. Python lists and tuples start at index 0, so the first element is called 0, and that's not just to be frustrating, that's because it actually reduces bugs. There's some interesting papers from many decades ago talking about 0-based indexing is better than 1-based indexing. It makes a lot of calculations easier once you get used to it. So what this does, this is actually not a name assignment, right? So earlier I said, M equals in the list, that's assigning or binding the name M and the name N to an object. In this case, this is actually a request to the object that M refers to change index element 1 to be that object instead. And I'm saying the request is like message passing, the old metaphor for object-oriented programming with methods, right? So this object tries to change itself. The M object, the object M refers to, tries to change itself and say, oh, let me go find index 1, the second element, and whatever was there, get rid of it and put a B in its place. Oh, sorry. And whatever it was referring to at element 1, make it refer to something else instead, right? I'm sort of switching between talking about variables colloquially and the way Python's doing it. And so now you look at M and you've got 1, B, and 3. So if I asked the object that M is bound to change index 1 to B, will N, the name N, the object it refers to, will it also show up as changed? The answer is yes, because it's the same object. So we asked the object. We didn't ask the M or the N. The object doesn't even know its name. It just knows it's a list. Okay? All right. Any questions on all that? All right. We're going to go a little bit faster. A little bit faster now. Okay. So let's just explore numbers a little bit. Oh, okay. 1 minus. Yeah, that doesn't really make much sense. Minus 1 means negative 1. So minus you can either subtract or say something is negative. And here's how you get a syntax error, and it shows you the line that failed, and it shows you where in the line it failed. That's what that little hat or caret means. It says, at that character is when I couldn't figure out what you meant. That's reassuring, actually, that I can't assign to a literal. I can't make the literal 1 have a different value. It's always going to mean an integer 1 in Python. Okay. There's equality. There's inequality, the not equal. Used to have the other one, less than, greater than, as a not equal. That, I think, got removed in Python 3. So it's always this one instead. Is 1 less than 2? Yes. Is 1 less than or equal to 1? Yes, it's equal to 1. So it is less than or equal to 1. Is 1 greater than 2? No. We can do math. That's pretty good. 1/2 in Python 3 gives you 0.5. That was a big change from Python 2. Fixed one of the problems with design problems from Python that was figured out to be a design problem long after the fact. This is floor division, which basically does an integer divide, rounds down. Okay? This is a modulo operator, or otherwise known as clock arithmetic. Right? If it's how many times does 3 go into 9? 3. And how many are left over? Well, 0. It divides evenly, so there's the 0. Whereas if you divide that way, you get 1 left over. It's the remainder. Sorry, double click there. Int is callable. I can pass 2 to the int callable and get back the same thing. If it takes it'll take a float. It'll take a float that's not equal to an integer, and it'll truncate it. It won't round it. It'll convert from strings, but it draws the line somewhere and says, sorry, that was a float. You want me to convert that string that's a float to an int? It's not a string int. It's a string float. It stops there because you wouldn't want to do that one by mistake. Okay. This error is kind of interesting, value error. So we've seen name error and syntax error. Well, now we have value error. Invalid literal, which is the string literal, for int, which is what we call with base 10. So it's maybe there's a clue there that you can actually use other bases. And of course, it's not going to magically figure out that you speak English and want to turn that into a number. So it's pretty strict in terms of, and narrow in terms of how it interprets it. Okay. Float 2 will convert from int to float. It'll convert from strings, including floating point numbers. This will give us another error, 0 division error. At what line? Can we add types that are of different types? Sometimes. Floats and ints you can. All right, a equals 1. Yep. Yeah, we've seen that. A plus 1. So look up the name A in the namespace. Find the object it refers to or is bound to, which is represented like that. Go find or create another object, which represents the integer 1. Add those two numbers together to create a new object, which is going to be an integer 2, and display it. Great. So now what is A? What is A bound to? Yeah, it's still 1. I didn't change it. Right? And now I can bind. So it showed me the 2, and then it stopped using it. It didn't have a name anymore. So if I want to give it a name, I put the name binding in front of the assignment. Here, it is going to change what A is bound to, right? It's not going to change what's in the box A, because that's not the way Python does it. But it's going to look up the 1, create another 1, add them together, create a 2, and then bind A 2. So in this line, it looked up A as 1 and now binds it to 2. Okay, so it's changing that namespace. A plus equal 1 lets us do that or something very similar to that all in one line, and we get A3. This operator is actually its own. It's not just syntactic sugar for this. This actually tries to ask this object to change itself in place, but integers can't change their value. Lists can, by change their contents or what they refer to. If it can't change itself, then it falls back and does that. So that's a little bit behind the scenes, or a little bit more depth of what actually is going on. This you'll see, you may be familiar with from C++, doesn't exist in Python. That's a conscious choice. Okay, these are pretty straightforward, I think. Oh, okay, let's do some math. So sign pi/2, name error. There is no sign name available to us in Python. We didn't put it in the namespace, and it's not part of the built-ins. There are about 50 built-ins that you get for free that don't show up when you do a dir, but they are accessible. Sign is not one of them. Right? So it's not in this sort of hidden namespace, and it's not the ones I've created. Import math, as I showed you before, will add math as a name to the current namespace and make it bind it to the math module, which has a whole bunch of attributes, including sign and pi. So will this work now? Is the name sign defined in my namespace? No. Only the name math got defined in my namespace. Right? So there's the math that got added. If I look at the attributes of that object, there are lots of them, including, somewhere over there, sign, and wherever pi is, there it is, right? So I can type this, and it will work, right? And again, what's going on here? Python looks up this object, asks that object for this name, and gets back the attribute, which is a floating point object representing pi. It goes and creates a floating point number representing 2. It does the division, takes that object, sends it off to whatever the lookup here. You get the idea, right? So we get the number. You can do from math import sign pi, whatever you want, and what that will do is it will go find this module, which already was imported, so it doesn't re-import it from the disk. It just says, oh, I already know about that one because I did an import of it earlier. And I'll go look inside it for those two objects, and instead of putting math in the namespace, it puts sign and pi into the namespace, right? So sign refers to math.sign now, and pi refers to math.pi. Now I can just say sign pi over 2, and it works. In general, this syntax is not recommended when you're writing code that's going to live for a long time and lots of people are maintaining, because it doesn't take very much effort to write that over that, and then it's very clear to the reader exactly. This is very clear to the reader what's going on. Ah, you're talking about the sign from the math module, not the sign from the NumPy module, or something like that. Yes?
Does that take a performance hit since it has to load the whole module?
Does this take a performance hit because it has to load the whole module?
The other form.
No. So when you load a module, it loads the whole module. Unless in a few cases, the module is smart and will sort of auto-load certain pieces. But something like the math, it just loads it in because it's fast to get it in. So it's pretty rare that you have really large, complicated modules that incrementally load, and when they do, it's usually hidden from you. Help is a built-in function. You can pass it an object, not a name. It's Python looks up this, gets an object, passes it off to help. And based on that object, help says, oh, I'm going to tell you about that object. And so if that's true, how did help know to use the word math and the word sign? Well, it's because the object itself knows its own name. I told you objects don't know their names. In a few cases, they do. Modules, classes, functions, when they are created, the name is stuck in there, or reference to the name is stuck in there so that the documentation works. Again, more implementation detail than you need maybe, but some of you. So when I sort of do those little digressions like that, if you don't get it, don't worry about it. We'll just keep going. Okay, your turn to do a few exercises with numbers. Okay, let's move along. So a number of you noticed in this set of exercises a couple things. One is I introduced new things in the exercises, and that was intentional. All right, I'm not going to do what Knuth did and offer you double $1. You know, the first person who finds a bug, I'll give you $1. The second person, I'll give you 2, 4. But I'm almost positive there are no errors left in the exercises. They're all intentional. So when you get an error, it's because I wanted you to get the error and look at it and think about it. When you see an R in front of a string, I want you to think, well, what is that? Can I figure out what it is just by looking at the code? And then I'll explain it in the exercises. So yes, get a little bit frustrated, enough to make you think harder, but if it really bugs you and if you're going to hate me for it, well, tell me afterwards and I'll clean it up, because I don't want it to be too frustrating. Can't remember what else. I think that was the only thing I noticed in terms of the questions that were coming around. But let's look at these. So create an integer, add, so we can do equals 1 plus 2 less than 3. So is this going to say is 3 less than 3, or is 1 plus 2 less than 3? Well, the answer is going to do 1 plus 2 less than 3. There's a notion of operator precedence. The Python documentation tells you what comes first, which is binds more tightly than others. I'm not going to explain all that now. You can look it up. Or you can put parentheses around stuff when it's not clear. If it's not clear to you, good chance it won't be clear to other people. So it doesn't hurt too much to put in extra parentheses. It makes your code a little bit unreadable, a little bit less readable for people who already know it. And once you get to know it, so you should try to learn some of them, but don't worry about learning all of them. This is one of the things I didn't tell you about, but you can, in Python, you can say is 1 less than 2 and 2 less than 3 all in one line, all in one expression, which is kind of convenient. Is 2 less than 1 and 1 less than 3? Well, no, because 2 is not less than 1. All the Boolean operators like and or in Python are short circuit, meaning it won't evaluate them all. It'll evaluate until it knows the answer's false, and it'll stop. Unless it's an or, then it keeps going. 3 star 3 means 3 raised to the 3rd power. Round 1.01 is going to round up or down, depending on if it's 50. One person noticed that round of 2.50 goes to 2 instead of 3. That's because computers don't store floating point numbers the way we look at them. They store them with base 2 using a IEEE 754, I think, or 854 is the standard. That's the standard that all computer hardware uses. So it's predictable what it's going to use, but it can't store arbitrary precision. So there are some rounding errors that will happen. And that's one of the reasons why people talk about dusty decks. These algorithms were written back when people wrote using card decks, and once the experts, math experts who do numerical analysis, figure out how to write that algorithm so it doesn't drift one way or the other with these little tiny rounding errors, then they don't want to touch it, because to get that provably right is really hard. So when you import Python libraries, especially from SciPy, you're occasionally importing Fortran code, for example, stuff that's been around a long time and is tested and true. It's easier to upgrade the compilers for modern architectures than it is to rewrite code. Cheaper, easier, safer. Okay, so I round that. So here you notice that here's an example where I have round takes an argument. Well, actually, now I can give it 2. So Python has this great feature, which is optional arguments. Round, you have to pass it at least 1 argument, but you can pass it a 2nd argument. And in this case, if you look at the documentation for round, it'll tell you what that 2nd argument does. And it basically says how many decimal points after the decimal. But what if you put in a negative number? You'd think that might give you an error, but someone thought, well, yeah, it's obviously an error. But there's a nice feature we could add, which is how far to move the decimal point the other direction. So you can round that way as well. And there are a bunch of sort of Easter egg-ish kind of features in Python like that, where once you know they're like, oh, that's really handy. Okay, advanced exercises, again, all of the exercises sort of start easy and get harder. So by the time you get to the end of them, hopefully you're thinking really hard, and most of you won't get that far. What here? Type, callable, help callable. Okay, so this tells you a little bit more about what the callable function does. Yeah. All pretty straightforward here. I don't think there's much I want to talk about. because there's more interesting stuff we'll keep going to. Oh, here's where I said, okay, int with base 10, so what about that? Also base 10, but I can do this. So a second argument to int is the base. So C in base 16 hexadecimal is 12 in decimal. Any questions? Okay.
When you did the callable, the help callable?
Yep.
Just second argument of the slash?
So the help callable, he noticed that the second argument was slash. So that means no more required arguments after that. That's a fairly new feature in Python that it shows up with that slash. So that's a documentation. It's not actually it's not the name of the second argument. Because you can't have the name of an argument if you name it. You can actually pass names. I'll show you that later. It has to be a valid identifier. Anyway. Okay, so strings. Here's a string. Same string, right? So you can use single quotes or double quotes, whichever you prefer. Some people prefer double quotes because they're more like C. Some people prefer single quotes because they're slightly easier to type. And they are Python's canonical representation. You see that here we entered a string literal. When it shows us a string literal, it will use single quotes as, when it can. Well, what do I mean when it can? Well, okay, I want to put a single quote in that string. How do I do it? I can't do it that way because it gets to there defines the string, and then it sees this S all by itself, and then a dangling unmatched single quote at the end. So I could either put a backslash in front of it, which escapes, it's called, escapes the quote. Right? So Python, when it sees the quote, it says, you're starting a string. And it remembers that, and then it starts adding characters to the string. So T is the first character of the string, not the quote. When it gets to a backslash, it says, whatever comes next, I'm not going to do what I usually do, which in this case is end the string. Instead, I'm going to actually add that character to the string. And then it keeps going, and when it gets to this one, which is not escaped with the backslash, it says, okay, that's the end of the string, because I was looking for, I got a quote, and this is the second one, therefore it is the two ends of the string. Okay, so you can do that. Notice what Python does. It gives it back to you in the way its best effort at representing the string. It puts double quotes around it and a single quote in the middle, which is a lot easier to read. So that's one of the reasons why you can use double or single, is it makes it easier to write things with quotes inside them, like this, like this. How about 2 lines? No, doesn't work. But that does. So if you use triple quotes, single, apostrophe, or quote marks, you can have multiple lines, new line characters in the string. So you hit enter, and this is whether you're in Python code or at the interactive prompt. Now in Python code, if you're doing it inside a function and it's indented, then all those spaces that are indenting it are going to be part of the string. Okay, here I want to put triple quote around triple quote, so I want a single quote there and a pair of double quotes there. It doesn't know what to do, right? So it's got the 4 quotes in a row and it got confused. This is one of those edge cases where in theory, the people who maintain Python and are improving it could go make that work, but is it worth it? There's other ways to do it. So it just gives you an error and keeps the language faster and easier to maintain, being less code. This will work. Here's the other way to put new lines in, of course. Like up here, we put a new line in by hitting enter. On the space there, that's because at the interactive prompt, it always puts in a space as part of interacting with you typing. In is an operator in Python. Operators aren't just pluses and minuses and slashes. They're words sometimes too, like the in operator. So is the string EL in the string hello? So is it a substring? Not in is also an operator. Those of you who are familiar with other programming languages, you might find it funny that this not isn't over here. It's because not in, 2 words, is a single operator, which means the opposite of in. You can also say not EL in hello, it would work. But the not in is easier to read. And there's lots of things in Python that are done to make it easier to read, make it much more like you're reading, like you would be speaking. All right? So a string is stored in Python as a sequence of characters. A single character in Python is stored as a string of 1. Right? So there's not a separate character and string type like there is in some languages. A character is a string of length 1. the string, you can access elements of it. So here we use the square brackets to access the element at index 0. That's the way I would say it, which is going to be the H. And we get back a single character, i.e. a string of length 1. So it's the same type. So this single character string and this multiple character string, they're the same type, the type str. Are those characters stored as bytes or 2 bytes or 4 bytes? The answer is, it's none of your business. You shouldn't have to care, right? In Python, this string representation is an abstraction of whatever was on the disk or whatever came in over the network. It's an abstraction that's trying to represent at a high level, closer to where we think about things. It's a string of characters, right? And if those characters are Klingon or Korean or French characters, whatever, it doesn't matter. Python knows how to handle those. When you put stuff on the disk, then you need to worry about it. When you read stuff off the disk, you need to worry about it. And I'll show you some of that later. Okay, let's bind S and T to the same object. There they are. I can look at them. So here you notice if I evaluate, you've seen this before, just a reminder, when I say S comma T, Python says, oh, you must mean a tuple. And so it interprets that as a tuple and returns you a tuple. That's why it's putting the parentheses around it. It's handy for to be able to do that, though, in several cases. So this is going to look at the ELLO and look at the J, create 2 string objects from those literals, concatenate them, which is allowed in Python. When you use a plus on string types, it puts them together, and return a new string object, Jello, and bind S to that. Ta-da! What's T? That's right. Okay, what's this going to do? Is it going to change Jello back to hello? Strings are immutable. That's right. Strings and tuples are immutable. Ints are immutable. Floats are immutable. It means they cannot be changed. And the way it shows up here is string object does not support item assignment. So someone out there said it answered the question incorrectly. Good for being courageous. Keep answering incorrectly. Just don't be afraid of answering the wrong answer. We're here to learn stuff. Yes?
I was curious if there was an example earlier when we were pointing two variables to the same object, and then when we were changing one of them, was changing the other one, and why wasn't the case here?
Right. So why was it that before, when I had 2 lists, M and 2 names and 1 list, I had a list object where I said M equals N equals list, and I then used M sub 0, M square bracket 0 equals, and I changed. That's because lists are immutable, and the equal in M square bracket 0 is a request to the list for it to change itself. In this case, I didn't use the any square bracket, so here it's actually, this is a request to Python to change the binding of S to point to the object that gets created by the right-hand side. Okay. So yes, good catch that those seem to be behaving differently, and they sort of did and they sort of didn't. So partly it's because the list example earlier, we had M sub 0. So I tried to do that here and I can't.
Yeah.
So that's why I had to do it that way instead. Okay? But I don't like the fact that I have to go back, so I'm going to make a note to fix that. Okay. All right, so S is still Jello. It didn't change. Okay. What's the B? Oh. In the exercise, the strings. Oh, someone was working ahead. They were noticing the R in front of a quote. You were working ahead, I think. Okay. So what's the B mean? The B means bytes. So in Python, there is a bytes type, which is really great, but it's actually a little bit confusing. This is the first time I'm trying the next treatment here, so be sure to write down notes if you can think of ways to make it better. But what this does is the string type is an abstraction of characters. The bytes type is bytes. It's like 1 byte, right? But you notice I didn't have to put in the integer numbers that represent these characters. It assumed I meant ASCII, and it translated the H into the number for me, and the E into the number for me. And if I look at the type, it's of class, it's the type class bytes. It's the type bytes. S1 is hello. B1 is be hello. Are these equal? Who thinks they're equal? Raise your hand. Who thinks they're not equal? Raise your hand. Oh, fair number of you know that they're not equal, right? So why aren't they equal? It's because by making them not equal, it helps prevent you from writing bugs. So character encoding was one of the things that was well supported in Python 2, but the way it was supported made it confusing and it made errors lag. It did the friendly thing, which then you regret it later. Python 3, you regret it right up front. It tells you right up front, no, you can't do that. So you can't compare, and that makes total sense, right? If there are bytes on the disk, if I've got, a byte which is, 220, followed by a byte which is 13, followed by a byte which is 7, and I compare that to 3 characters, well, they're not the same. One is integers and one is characters. The fact that we use integers or numbers to represent characters, that's the confusing part, or the part we have to make sure we think carefully about the difference. So what if we want to take those bytes, the numbers that are in here, and turn them back into string characters, into characters in a string? This is how I do it. I decode, right? So we take characters, we encode them in bytes on a disk, in a file, or over the wire, like a network protocol. So if I decode them, then I can compare it to the string. So if I take what looks like a string but is actually bytes, and decode it into a string, then it actually is the string hello, and it's equal to the string hello. Okay? I'm going to keep going here. What if I take S1 and call encode on it? Well, S1 is a string. When I call the encode method, it's going to return me an encoded version of that string, encoded in bytes, and it works. Now, why did it work? Partly because it encoded it with a default encoding, which is UTF-8, and UTF-8 encoding for hello is the same as the bytes. ASCII hello is basically where I'm going with that. So as long as you work with ASCII, which is 7-bit, then UTF-8 is identical. As soon as you go past those first 127 characters, then UTF-8, you start to get different numbers of bytes per character sometimes, and how many, it depends on the character. Anyway, your turn to do some exercises, and I'll wander around. Yeah, one more comment. So I said that the way I'm doing the bytes and the encoding and decoding, I put a lot of that in the exercises. So when you get about half done the exercises, I'll stop us and go through it together. I probably should have moved some of that around. Okay, so I think close to, I think most, more than half of you have gotten about a third of the way through, and I'm going to change the structure here, and I'm going to do the second, most of this is, I'm not going to let you finish the exercise, I'm going to go through them slowly. And I had planned to shift that section around and forgot to do it, so to have more of it in the lecture and less in the exercises. So let's look at this. So if you put an R in front of the string, it doesn't do much to that string. It just seems like it's a different way to do the same thing. But here, look what happened. So R spam is spam, R spam with a backslash n, it put a double backslash in, right? And the R stands for raw, I think, which seems kind of a funny name, but basically it means don't do any special processing on the string, i.e. don't interpret backslashes as an escape character. So when it sees a backslash, it puts it in. And then it displays it to you with a double backslash without the R, because this is what you would have to type back in without the R to get the same string as you type with the R and a single backslash. Okay? And again, the exercise here was trying to get you to figure that on your own. And if you don't, that's fine. It just helped you to work your tiny gray cells, as Poirot would say. And you can see those are the same string, right? So if you put the, no, these are not, right? Why are these not the same? Because this one has a backslash character and an n character, and this one has a new line character, which is what backslash n gets interpreted as in a regular string. And you can see that the length is different, right? So one's got one more string than the other one more character in it than the other. Okay. Yeah, I'm going to skip that one. So you can multiply strings, which is basically concatenate multiple copies of it. We saw you can concatenate strings before, but you can't concatenate strings to other things, at least not those. But you can turn it into a string, and then you concatenate them. Okay. Oh, that's kind of cool. If you have two string literals next to each other, Python assumes you want to concatenate them, so it'll do that as part of parsing. All right, there's a $sign. There's Unicode code point 24. Oh, it looks like a $sign. There's a Unicode named, I can't remember exactly the right term for that, but Unicode is the standard we use for encoding characters. But the Unicode standard is not, sorry, I have a pet peeve. What is that file encoded in? Well, it's encoded as Unicode. No, Unicode is not an encoding. Unicode is a standard that includes things about encoding. So if someone ever says to you, it's a file encoded in Unicode, you have to say, okay, which one? Unicode 8, UTF-8, UTF-16, some other character encoding. So this is the, there's a table, hundreds, thousands, tens of thousands, I think, of characters, and they each have a name. And this is the Unicode name for $sign. And you can use the \N to actually enter a character that way if you want. And you can see that these are all the same character. Okay? Interesting, not really helpful. It happens to be that those three are also stored in the same object. Strings are immutable, so it can do that if it wants to. But not every Python implementation will do that. Again, just think about equal. So let's do a few things with that $. So if we encode that, looks like it's the same except the B in front. So when you encode it, it turns it into a bytes object. And they are different, as you saw earlier with, was it hello? The string hello. And if you look at you see the types are different. One's string and one's bytes. It's a single byte long. Let's encode it and take its first element. I didn't say character on purpose, because it's not a character. Bytes don't store characters, they store bytes. What's first? It's an int. So that's interesting. If you take a bytes type, like, where was it? First. So $encode, you turn that into bytes. Well, hello, for example, the bytes type hello, the bytes object hello, it looks like HELLO. It's not. It's actually whatever the number is. It's a list of integers, but it's sort of intended to be used for encoding characters, right? So it's kind of interesting that when you take the bytes type, let me have a better example of that. Hang on a second. Okay. Right, like if we say be hello sub-0. That's kind of weird, isn't it? So what's weird is, and this is the trick, to, if you're new to character encoding and you think, I encourage you to just remember that when you see a B, it's lying to you. It's letting you enter the characters because it's convenient, but it's not storing them as characters, it's storing them as bytes. And bytes meaning lower level down on the disk. Okay? Okay, so if we look at the types of these things, we got, string, bytes, and int. If we look at the dollar, string, the encoded version, and accessing the first element of it. If I take that 1036 and call the CHR function on it, it will give me back. So CHR and ORD let you map from ASCII values to ASCII characters. I can turn it into binary, a string representation of it. Okay, let's take the pound sign and do something like that. So there's the pound sign character. Some of you might not be able to display it that way. It depends on what version of Python, what operating system, what shell. So whether or not your shell actually can display characters beyond ASCII depends. If I try to turn that into a string, well, yeah, what would turning that into a string be? Isn't this a string already? The answer is yes, it's a string. It's of type string. If I do a repr of it, well, repr, all that's going to do is show you what you would have to type. Here's a string of 5 characters. The middle 3 characters from the quote and the pound and the quote, that's what you would have to type to get it back in if your interpreter interactive prompt can let you type in those characters. I can turn that into an ASCII, and I get XA3 using a certain encoding. Okay. Okay. Let's look at encoding a little bit more, and then we'll move on. So encode we saw earlier. Encoding UTF-8.
Is there a break?
Break is at what time? I think it's 3. Someone look it up for me, please. I think it's 3, but yeah, I'd like to know a few minutes before. Thank you for that reminder. So if I encode the pound sign using UTF-8, it actually gives me 2 characters. 2 bytes, 2 values, right? So if you take the pound sign and code it with UTF-8, which is by far the most popular encoding on the web, has been for almost a decade, not quite, you get 2 characters or 2 bytes to represent that. Sorry for giving you all this detail about encoding. You need to know about it, otherwise you'll get into trouble and you'll just like, argh. If you know what you get into, then it's not so bad. What time's the break? Anyone find out yet? Okay, thanks. So we think it's 3 o'clock. So UTF-8 is the default encoding. I can pass it or just give it no argument. It'll assume that. It's 2 bytes long. Those are the values of it, right? So you notice if I take that and try to enumerate over it, I get the integers out. When I call list, it just says whatever it is, iterate over it and give me the elements individually. So that's why I get the list back with those 2. And I can get the first one, the 194, and look at it as bytes, and the second one look at it as bytes. And here is where you'll see in basically if this is a 1, this is just for your information, if the first bit is a 1, then it's the start of a multiple character UTF-8 character, multiple byte UTF-8 character. If it's a 0, it's not. And so in this case, so with UTF-8, when basically you're running along and you say all these bytes that are less than 127, or 127 or less, and they all start with a 0 as the highest bit, most significant bit. And so I'm reading UTF-8, 0, 0, 0, well, it's just ASCII, 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 ASCII. I get to one where, it starts with a 1, then I read the byte, figure out, okay, is this 1, it's going to be 1 more character, 2 more characters, or 3 more characters. It reads those in and turns it into a Unicode. Behind the scenes, it's stored something like that. Okay, what else here? Interesting. So if I encode that with Windows 1252, which was the most popular encoding on Windows, I'm not sure if it still is, depends on how you measure it, it's a single character. If I encode it as ISO 8859-1, which was a popular HTML encoding, it's the same as Windows 1252. How about the euro sign? The euro sign in Windows 1252 is that byte. In UTF-8, it's those 3 bytes. In ISO 8859-1, it's not possible. So this is why if you're doing stuff, you sometimes need to worry about encodings and how to do things. Always use UTF-8. Always remember that characters are encoded at a high level of abstraction. When you go to bytes or come back from bytes, you have to worry. You have to know what you're encoding from or to. Can't do it that way. I can use the ignore on the encoding, and it'll basically drop the ones it can't convert. Or I can replace them, say replace, and it'll replace the characters it can't encode with a question mark instead. Some interesting features. Okay, string functions and methods. Any questions about all that encoding stuff? I think that was the first time I've presented this material. I think I've got a lot of changes to make it a little bit simpler, a little bit easier. More feedback would be welcome. Yes.
What was the first character when the dollar sign or the pound sign was the character?
What was the first character?
Yeah.
It wasn't. It was 2 bytes.
Okay.
What was the first byte?
Yeah.
Oh, you could convert it and find out. I don't know what the actual number was. I let Python worry about that. What's that? There you go. And you can't. There's no one answer for it because that first character changes. That first byte changes depending on where in the Unicode code space in UTF-8 it's trying to get to. So encoded in that first byte, I think you can have. I'm not a UTF-8 expert. I think in that first byte of a UTF-8, more than one character representation, like a 2 byte, 3 byte, or 4 byte UTF-8, I'm pretty sure that first byte actually, some of the low order bits can change too. I could be wrong on that though. Okay, yes?
I'm not sure exactly how to ask, but so I understand there's a way to represent the character that's in the binary, and then there's the character, and there was another thing,
Bytes?
right?
Yeah.
Yeah, I'm confusing.
It is confusing. Here's the summary. When Python's running and it's doing things with strings, like you're saying, is this uppercase? Does this string end with an S? You're dealing with characters, and the characters can be anything. Hindi, Arabic, Korean, English with an accent, imported from, whatever, all sorts of stuff. When you want to store that on the disk, you have to choose an encoding to use. You can't just say, well, use the one that everyone uses, because everyone doesn't use the same one. There's some stuff that's encoded as ASCII and only has 127 characters. There's some stuff that's coded as Windows 1252 and has 256 characters. Well, not quite. There's some stuff that's encoded as ISO 8859-1 and overlaps with Windows 1252 a lot. It's almost the same, but there's some that are different. And then there's stuff that neither of those can encode at all, like the euro. So you have to choose an encoding. The short answer is always use UTF-8 and you'll be happy, as long as it's supported all the way downstream, including the database. How many characters can be encoded in UTF-8? Yeah. It's 256 to the 4th power, almost. Lots. Right, because I think 4 byte characters are the largest in UTF-8, and except for the first few bits, any of them can be used to encode that. So Unicode has tens of thousands. I think it's in the 50,000 range, or maybe more. I don't keep up.
So what's the difference then between binary and bits?
The difference between binary and...
I know bits, but they're the zeros.
Right, so the bits, I'm just saying, I use the word bits to mean on the disk there's bits on and off, so it's actually the number that's represented in binary. The bytes type is the way, a convenient way to store a list of integers in a compact format that's almost always used to convert between encodings, between encoding characters and unencoded characters. That's all it is. And that's why it looks funny, is when you look at it, it'll often show you characters, even though it's actually storing a list of integers. Okay. Okay, string functions and methods. I think, so the break is at 3, then I'll get through at least some of this, maybe all of it, and then you can either take your break early or late or whatever. Choose when you work on the exercises. We'll see. Length for min. What does it mean to take the minimum of a string? Well, min is going to iterate over this object. When you iterate over a string, you get 4 strings, each of length 1, and it's going to show me the smallest character in terms of the earliest in the way it's encoded. Is historically how it was. Max works sorted, always returns a list. Does that string start with an S? Does it start with an S and a P? Does it end with an M? Give me an uppercase version, give me a lowercase version. Take the white space off the front and the back, new line, tab, space, vertical form feed, all those things, just rip them off. Actually, no, just take them off the right side. Oh, no, actually, just take them off the left side. Okay, take off, now this one's confusing. You might think this is dropping the CSV, the .csv from the end of a string, but it's not. This is actually dropping the dot or a C or an S or a V from the right side, which doesn't look any different there. But here, it does, eh? And here it certainly does, right? So this one's a gotcha that some people get confused about. So R strip and L strip take a string and it looks for any character in that string and rips it out, okay? Split is a method on string that returns a list of strings split on any white space by default. If you give it an argument, then it's not going to take the default of any white space. It's going to use exactly what you give it. So here it's going to look for the 2-character string, comma, space, comma, space. And there it's the end of the string, so it doesn't matter. Whoa, look at all those methods. I did a dir of str, or maybe a dir of the string. What would I do? A dir of the class itself, or the type itself. There's lots of methods on there. Let's just look at what they are. Well, that's a little bit easier to read, but there's lots of them. If I look at the string or the type, they're the same, which is mildly interesting for those of you who know what's going on behind the scenes a little bit, or have more programming experience. Index says, please find that string in the larger string. So look for that string, PA, in the string spam, and it finds it at character offset 1, 0, 1. So there's the 1 and 2 are the is. Index is just like, oh no, index will raise a value error if it can't find what you're looking for. Find is just like index, except it has different behavior when it can't find the string. These are all fairly straightforward. Oh, I can replace the E with a 3, all E's with 3, or just one E with 3, and that's it. So start the break now, come back at about 3:15, 3:18. You can work on the exercises now or later. If you want to break, snack, coffee, you probably want to go out now instead of later. Shorter lines, spread it out. Before I formally start, how many of you have finished the exercises? How many are at least halfway through the exercise? Anybody not even started yet? Okay, I think we'll go ahead and move on. As in, I won't walk through the exercises. Okay, welcome back from the break. Some of you had time to work through some of the exercises. I'll go through them now and show you what you missed or the ones you didn't get to. Before I do that, had some couple comments, helpful comments on the UTF-8 and encoding. those pieces. And a blog post, was it Joel on Software? Very good old blog post on understanding encoding. There's a bunch of good ones out there that explain encoding. Again, I don't know if you need to know the depth I put in here. I'll probably simplify it for next time, but understand at least about encoding the two levels of abstraction, that you can't mix them easily, and when you do, you have to be explicit on what you want to do. So if someone gives you a file and you just open it and read it without asking them what encoding is that file, then someone's made a mistake. Like, you need to know what encoding a file is if you want to safely get the characters out of it. And similarly for a stream of data, it's usually not as important to ask because it's usually encoded in the headers between like a browser and a server. It's already, that negotiation happened for you. But if it's just a file on a thumb drive or emailed to you, find out what the encoding is. Okay, so exercises here. So sorted spam. Again, we're supposed to think about what's this going to do. Well, sorted is a function that takes any iterable. String is a kind of iterable, a list is a kind of iterable, a tuple is an iterable, a dict is an iterable, there's lots of other, a file handle. And then it pulls out all those elements, which for a string are going to be the individual characters represented as strings, and puts them in sorted order. Let me get rid of my little sidebar there. You can pass an optional character, optional argument reverse equals true, puts them in the reverse order. Reversed is a built-in function that takes an iterable and returns a reversed object at a particular address. So many, over time, Python is slowly and steadily marching towards more and more lazy evaluation. So don't evaluate until you have to. Generators do this, a lot of functions do this, the views on dictionaries, etc. So in this case, the reversed object won't give you them in reversed order until you ask for them individually, and that in many cases can be more efficient because it's not putting stuff in memory you might never want anyway. Well, in this case, it's all in memory anyway. But if you want to iterate over something to see what's actually in it, like a reversed iterator, you want to do the iteration, the easy way is just pass it off to the list built in. It will iterate over it for you and return the list. Okay? Upper is upper, title is title. See the pattern there? There's a bunch of them there where the is the predicate function, or predicate method it's called, because it answers a yes, no question. And title returns a title case version of the string. And you can see what title case does with spaces. Swap case, right? So here we've done what's called method chaining. We called a method, so this object, this method was called on it, a new string object was returned, which was spam eggs in uppercase, and then the swap case method was called on that object to swap the case. So method chaining is becoming more popular, especially in some libraries in Python. Is that string substring? Is PA a substring of the spam string? Is the exclamation point in that string? Okay. Willy-nilly find ill. It's at index 1 right there. Find the first one that starts after 6. That should be that one. There we go, offset 7. Anyone get through far enough? It's not going to work for me because I didn't define S. Anyone figure out what s.index0 s.index space does?
Oh, this didn't work because S is defined, but it's not assigned hello world yet.
Oh, so in yours, S was defined. Thank you. That's helpful. Whereas mine, it was not, because I had reset my interpreter. Right, so if we set S to hello world as an example, which I think I did next, and then go back and do it, well then we see, I mean, basically what's going on here is that s.index says look for the O, but starting at this character position, where this character position is whatever s.index space returns. So it's going to start looking at space to find the O, so it's going to get the O there. Okay? Yeah, and then you can see, yeah, build it up and see. Okay. Count the spaces in a string. How about I check for more spaces than non-spaces in a string? Think about how to solve that.
I want to use regular expressions.
You know that they say about regular expressions. If you have a problem that you solve with regular expressions, now you have two problems. Just because they're so, like for simple stuff, they're great. As soon as it's so easy to go over this line that's hard to see. It's in this visible line, and suddenly you're like, why did I write regular expression? So yeah, they're great, but just keep them small. Regular expression would work. You could do an S count of spaces. You could do a replace of spaces and count what's left. There's a bunch of ways to do it. I'm not going to actually go through it. Yeah. Oh no, that was not a question. Okay. Questions before we move on. So let me do a check. How many of you think I've been going too fast? Raise your hand. How many of you think I've been going too slow? Raise your hand. So at least within the bounds of people's courage to stick their hand up alone, I'm hitting the right stride. Good. And other feedback, welcome. There's a little comment box in the survey. I think you can type as much as you want. I'd like to hear it. I was chatting with someone over lunch who said, yeah, these surveys are a great way to get feedback, but sometimes it's kind of passionate, not very polite feedback. If you're so frustrated that you can only give me feedback online impolitely, I'd still like to hear that, because that's really important feedback for me to know. And I have, in teaching over the years, sometimes gone too far on the frustrate users to help them think, make them think. I've gone across that line sometimes, so feel free to tell me. I'd like to know. So print and string formatting. No difference when you're in the REPL. In script or code you're running, if you just put a 3, it's never going to print out. You have to actually call the print function. All right? I can call it with multiple arguments. By default, it separates the arguments with a space. Here you can see print 3, 4, it printed, and then there's a new line that got printed, just like the REPL printed a new line after it. So by default, there's a new line. You can put a \n to add another one. You can do this in Python 3. Most people are moving towards the .format operator or f-strings. So the way this works, and you still see it, is basically this % that I showed you earlier as a mod operator, like a remainder, is basically saying, please look in this string for %d and interpolate, is the official term for that, number into that string, so you get 3 good reasons. However, this is much more common in newer versions of Python since 2.6 or 2.7, I think. And so what happens here is it looks for curly braces and then matches the argument to the curly brace that's in the string. Okay? So there's the format built-in method. You can call it with no arguments, and there's nothing to interpolate, not a problem. You can call it with an argument that doesn't get interpolated because the string didn't have it. But if you say, I want to interpolate something and there isn't an argument to interpolate, then it tells you there's a problem. And there are good use cases for why it would allow these other ones. Because you don't, here we're playing with toy strings where we know the string, we know the argument ahead of time. Often in your program, you have multiple cases, and some runs or sometimes through the loop, you might have values there, other times you wouldn't. And you can simplify code by having these, at least in some cases, more relaxed interpretation, such as this one, where you have an argument but nowhere to put it. Yeah, that's no difference. So, hi class. I can use numbered arguments if I want. Used to have to use them, now they're optional. And that's advantageous if you want to change the order, which again, in this toy example, it's more confusing than helpful, but in real world examples, it would sometimes be more helpful than confusing. You can also repeat them that way. So there are good use cases, good times. It's good to have the ability to use numbered arguments. And then you can see like the :d here. Now again, reminder, I'm not expecting you to memorize all this stuff. Just let it wash over you and absorb as much as you can. Okay? So you're aware of all the things you can do. Just like strings, there's tons of things you can do with string. I would say, I think this is good advice. When you're trying to figure out how to do something in Python and you know, oh, yeah, I could do that with an index and a this and a loop, think, is this something that lots of people have done before and wanted to do before? And if the answer is yes, there's probably already a way to do it that doesn't involve you writing 5 lines of code. There's probably a method or a built-in function, and if Stack Overflow doesn't give it to you, just keep looking, because it's almost always there. Standard library, same thing. The standard library in Python is huge. People say it's batteries included. And for probably the first 6, 7 years of me programming, quarter of my time in Python, I kept kind of every few months like, oh, that's in the standard library? Why did I write that code 6 months ago? Because there's just lots of stuff hiding in there that, and I'm the type that reads manuals up front, like, oh, let's just read through the standard library manual, at least skim it to see what's there, and then I'd forget stuff. Okay, back to string formats. So :D is the way, so you put a colon after the missing argument here. So again, here the argument is just the implied first one, because it's the first in the string here. And then :D is a modifier that says, here's how I want you to format that argument. So I want to format it as a decimal, a number, or a number 10 characters wide, right justified, or same thing, but put the negative all the way at the left side, or explicitly right justify it, put underscores in front of it, left, slide it to the left of it, put it in the center, lots of stuff. What's that? Yeah, you can do that too. And I have some duplicates here. I don't know what that one does. Equal plus 5D. What's the 5? It's only showing count. I think it says, no? Huh. Oh, show, yeah, I can't remember. There's actually a good online resource called PyFormat, I think, .info or something like that, that just shows you lots and lots of examples. It's a really complicated, like there's lots of features, and I don't know nearly all of them. You can also put names in like this, and then give argument names like that to match them. Right? So, and in most recent versions of Python, you can use an F string, where it will look in the current namespace for greet and who. So if I have these names in the current namespace when the string executes, then it will find them and put them in. And that's, these F strings are like almost always far more readable than the .format version, because you can see the placeholder. Okay, your turn to spend a few minutes looking at the exercises. Okay, I'm going to move us along here, and I'll go through these exercises. So you notice you can take, that print takes default, optional arguments, like what to separate, what to use as the separator between its other arguments other than space, or what to use as a ending string instead of the new line character. If you want to have nothing as the end character, you might think that end equal and then give it an empty string would work, but it won't. Sorry, that end equal none would work, but it won't. You have to give it an empty string. And that's because the end equal none, that's the way almost all functions, when they're written, they say, well, this is a character that you can supply what you want to end with, or if you give us nothing, then we'll use a new line. And sending end equals none is like not giving it. There's no way for the called function to actually tell if you explicitly called it with none or just left the argument off. So that's a little gotcha that shows up in other places as well. Once you realize that's the way functions are implemented, it won't trip you up as much. Nothing new there. There we duplicated the 3 or the 4. Switch them around. All right, so here you can see that 7 is the width and 0.2 is how many decimal places. And those mean different things for different items. Like the S, if you say it's a string, then the dot means whether or not to truncate and how closely or how tight. B is binary. You can sort of play around hexadecimal, octal, percent, so it does the math for you and puts in the percent sign. Here it's print for me 1/3, 5 wide, 2 after the decimal point, and it's a percent. So here, notice that we have a curly brace pair, and inside it there's a curly brace pair exactly where you would expect to see how many digits after. And so there you can see how that works. Obviously, if you know up front what they are, just stick them in the string, but if this is a variable that changes with various runs or configuration or whatever, that's when it makes sense to use it. And you can even do something like that, where date-time objects, the date-time object has its own format specification. So when format method runs, it actually goes and talks to the object to say, well, do you have a dunder format method? And if so, it uses it to figure out how to do it. So you can write your own in theory. Sys.version.info is an example of a named tuple in Python. So it's like a list. It's like a tuple of elements that you can access by index or by name. And so, for example, here I can say pass sys as the argument, and then I put .version.info as the part of that argument I want. So yes, so then it's going to show me sys.version.info. Or I can pass, in this case I use the format, in this case I'm using the F string, so it's going to look for sys.version.info and just take, it's going to put the whole same thing in there. 398, I think that's a little confusing. Let me make a note. And notice in the F strings, you can put inside these curly braces. I mean, here I've got, take that piece out and multiply it by 3 and add 5 and multiply it. You can put almost any Python expression in here, which is not true for the .format method. The .format method, there's not quite as much Python you can put in there. There's a few restrictions, but not too many. So, and that can wait. I mean, like in my opinion, that's starting to get pretty ugly and hard to read. So when do you put stuff inside the curly braces? When do you put it in a format? Whatever's going to be readable, easiest to read by yourself or someone else 6 months ago is the way I answered a similar question. Think about readability. Okay, questions on format printing? Okay, tuples and lists. There's a list, there's a tuple. You can pass any iterable to a list and it'll create one for you. You can pass, you can access, you can ask a list to change its element at index 1. So it's going to, instead of referring to the B, it's going to, or 2, it's going to refer to the B. So it can change itself. They are mutable. I could take any iterable and pass it to the tuple built-in name, that callable, and it will create a tuple from it. And If I try to change the contents of a tuple, though, I'm going to get an error. Does not support item assignment. But you create them mixed, of course. There's no restriction that tuples all be the same type. The only place you see that all the things in a data structure need to be the same type are things like a little string. They all have to be strings. And then you see it in other libraries like NumPy, where columns have to be all the same type if you want to be fast. Okay, so can I concatenate lists? The answer is yes. And you see what happened? I got a new list. Those two lists stuck together, sort of. Of course, the original list didn't change. I didn't use plus equal here, I just used plus. Right? Earlier I'd used a plus equal, which says please modify the list, extend it. So here I added a list to a list. Here I'm adding a tuple to an int. And it says you can only concatenate tuple to tuple. Okay, so let's try concatenating a tuple to tuple. Read the error. What happened? So right here, not int. It's seeing an int there. Why? Well, because round brackets in Python are used both to create tuples, to call functions, and to enforce precedence in mathematical expressions or make them more readable, or both. So the 4 is being interpreted as not a tuple with a single element, but as the number 4. Well, that works. Okay, that worked for creating a tuple. No, it didn't. Look at that. So t equal 4, that actually said t is now an int, so that's not working. And it doesn't matter how many parentheses you put on, it's not going to help. But you can, let's see, how about here? Here, if I put ABC, it's going to give me a tuple. Here, I did tuple 4 and it gave me an int. Here, I give tuple ABC and it gives me a tuple of 3 characters. So if it can iterate over what you pass it, it will do so and put those elements in the list, in the tuple, sorry. If you need to create a tuple with a single element, you can do it that way. And you can see that it works. So occasionally you'll see that on output as well, like here, and that's what's going on there. So it's sort of this collision between the multiple uses of parentheses. We have this edge case that we have to handle, so a comma trailing is allowed, is required. And in fact, a trailing comma is allowed in lists and tuples and dictionaries, and that's quite handy when you have a list or and you split it across multiple lines. You'll often see a comma between them. Like you'll have element number 1, comma, element 2, comma, and the last element, comma, and then the closing square bracket. And that people, once you get used to it, it's more readable, it's easier to edit. A bunch of reasons why people do it that way. Oops, got an error there. I have a typo here. Let's do that. And that was at line 433. Is that the second typo? Is that $2 now? Okay, so now if I take the tuple T, which is A, B, C, I can add the tuple 4 and I get A, B, C 4 as a new tuple. Right? So you can do the math, as in concatenate multiple versions of itself. There's another way to create an empty tuple. A list BCDF, length 4, minimum, maximum, sorted, reversed, list reversed. I think you've seen all this in the exercises before. Why does this feel like repetition? I think I have another error. Is that $8? No, $4 now? There you go, just reinforcing, thank you. So m.insert 0a, what that does is it's going to insert a into the list m before index 0. Okay. What's that going to do? Someone said at the end. So let me read this one again. Insert a before index 0. So what's insert e before index -1? What is index -1 on a list? That's index -1. So if I insert e before the index of f, I'm going to get it e before f. Okay? So if you, someone asked me earlier about how do you read slices and where's you going to put it? Well, if you think, always think of before. In cases where it's, I think in most cases, maybe all cases where it's ambiguous, think about it as before. The index you're giving is you want to put it in before that. Put it in before that, and then it makes sense. And we'll see some other examples of that later. M.remove E. This is one that sometimes people get confused and think it's going to, if you pass it a number, it's going to remove an index. It's not. It's going to look for that element. So mRemove looks through the list, finding one that's equal to E, and removes it from the list. Now you notice it didn't return anything, so it doesn't pull it out of the list and give you a copy. It just asks the list to remove that element from the list. And what I couldn't remember, so m.pop will pop the last item and return it. Hang on. And what I couldn't remember earlier, but I'm sure I'm remembering right, but someone feel free to prove me wrong, is that if you had two E's in the list, it finds the first one and removes it. It doesn't go looking through the whole list. It says just remove the first element that matches that is equal to that. All right, so pop does return an element and remove the last one. So let's bind I to 1 and J to 2. Okay. So I don't need the parentheses. Here I'm doing, this is sometimes called tuple assignment or unpacking. Basically, if the right side is an iterable and the left side is multiple names, like an implied tuple that can be iterated over, it'll do multiple name assignments at the same time. Sorry about that. All right, so there's a tuple of 3. There's another tuple of 3. Are they equal? What does it mean for two tuples to be equal? The answer is it's that they have the same contents, meaning that each of their elements are equal. So when you say are two lists equal, are two strings equal, are two tuples equal, Python goes through looking at each element, and if it gets to the end and they were all equal, then the tuple is considered to be equal. The two tuples are considered to be equal. How many 3s are in there? You saw this before with strings, right? So a bunch of these are the same. Now this looks kind of weird, but it's really nice. Left side, right side is 4 elements, left side is 3, but the star says put extras in there. So what's going to happen is N3 will be 3, N4 will be 4, and rest will be all the rest of them. It doesn't remember the type on the right side. Like this is a list over here. It's just looking at this as an iterable. It iterates over it. It doesn't know that it's a list. It just puts them all into a list, it turns out. All right? So N3 was assigned 3, N4, 4. Rest was assigned 4, 5, 6. And then because I used commas between them here, it shows it to me as a tuple. But it's actually, it's doing the 3 name assignments is the part that matters. If I put it in the middle here, works. Cool. It can't be ambiguous, so it doesn't read your mind. So your turn now to do exercises for tuples and lists. Okay. Once again, I'm going to stop those of you who haven't quite finished and go through it as a group here. There's another one that exercise is pretty long. So, lists. Right, so you can see here that if you're going to use the plus equal operator on a list, the object has to be an iterable, such as another list. Also implies it doesn't have to be another list. It could be any iterable. Yeah, sure enough. Append appends an element to a list. And append appends an element to a list. Takes only one argument. Okay, so let's append an element to a list. And we have a list that contains, as its last element, a list of 3 strings. Okay. Let's delete that one. So before you saw m remove, here I'm saying do a del of m minus 1. This is not a namespace operation. It's a request to the list object that m is bound to remove its last element. So, and its last element is the list EFG. So I remove that, and now it stops at D. And if I use extend instead and give it an iterable, like a list, then I get the EFG added each of those. Okay? That comment I forgot to take out, I think. PA in spam. Yep, 5 in M, right? So similar. That's just too long. Right, so in here, just like in a string, here it's just looking to see if it's in there. And you can see that in and not in. Not in as a single operator or not, the expression with the in operator either works. Well, how about that one? 5, 6. I see 5, 6 in that list. Oh, no, I don't, do I? But now I do. So is that object in that object? So that list now contains 5, 6. Before it contained 5 and it contained 6, but as separate objects. That's interesting. M is 1, 2, 3, 4, 5, 6, 7, all the way up to G with some weird mix of integers and strings. N is 3 characters, 1, 2, and 4, 3 elements, and 1, 2, and 4. So Python lets me compare those 2 objects, and it will go through them and say, is 1 less than 1? Yes. M less than N. Is 1 less than 1? Yes. 2 less than 2? Yes. 3 less than 4? Yes. And then it runs off the end of this list, and it's done. So it says, sure, true. So you're allowed to compare lists of unequal length and any iterables, other iterables of unequal length. That's not a problem. So these are just doing lots of unpacking on the right to assign to bind multiple names here, multiple assignments. Do you notice any iterable works on the right side as long as it's the right length? So all these are unsurprising. There's a split like we saw before, gives us a list. Join is the reverse. So if you call split on a string, it returns a list. If you call join on a string, it returns, and pass it a list. If you pass a list to join on string, it returns a string.
Move back up just a little bit.
Sure.
Like right in the middle there, the IGK.
This one?
You get,
Line 520?
Yeah, why doesn't the IGK element OP show up
Show up where? This line?
in the result?
IJK, LMN, OP.
If it's your,
So this did the assignment. This is showing the values.
so P's not showing up.
P is right there.
No, little p is the variable, it's not showing. You assign IGK element OP, little p.
IJK, rest is LMN, OP. I think it is.
On the line above.
Anybody else seeing the problem? So what happens here is Python looks at this iterable, 1, 2, 3, 4, 5, 6, 7, 8 objects. And it looks to the left side, 1, 2, 3, 4, 5, 6, and says, okay, I can do the last two and the first three, and all the extras I will stick into there. Yep. You're the only one that asked. Some of the other people were thinking, they were wondering too. Probably. Oops, what happened here? So here I join on space. I can join on something like a comma space. I can join an empty string just to concatenate strings together. You'll often see that as a pattern because concatenating to strings one at a time is slow if you're doing big strings. Well, the computer's a lot faster now, so it doesn't usually matter. Occasionally it does. Okay, there's a list. M.sort, call the sort method on the list M, and it will sort in place. And it doesn't return anything, or more precisely, it returns none, the none object. Reverse, similar. Okay, let's start over again. I could do sort, ask it to sort itself in reverse order. Yeah, that works too. I can ask it to sort itself and reverse itself. Why will this fail?
Sort returns none.
So remember how method chaining works, is that this will create a list that looks the same as that one. This will ask that list to put itself into sorted order, and it will return nothing. And then Python will try to look up the name reverse on the none object, and it can't find it. So I'm going to get a name error or an attribute error on the none type object, the none object, which is of type none type. Sorry.
Is that true for any type of operation on lists that it doesn't return?
No, it depends. So some methods don't return anything, some do. So in this case, sort and reverse, I have a specific reason. There is a specific reason for that. Right? And I don't actually say it, but it's because there are built-in functions, sorted and reversed, and built-in and methods on list, sort and reverse without the D on the end. And by returning none, it makes it even more clear that if you used the wrong one by mistake.
If it was assigned to something, like if you had an assignment with sort and then assigned to something, would that have none?
So we could say m equal list, m.sort, m.reverse. That would work fine.
But if you said x equals m dot sort,
Well, sort returns none.
so x would be none.
Yep. Okay. And here's the sorted function. Well, it's not, though. I called it as a method. There's no sorted method. There is a sorted function. Okay? So sort and reverse are methods on list and possibly other objects. Sorted is a built-in function that takes any iterable and returns a list of those elements in sorted order. Okay? Any questions? All right, let's do some stuff with slice sequence. Yes?
Does a reverse does not return anything?
Does what?
Reverse is a,
So the method reverse is a request to the list to reverse its contents, and it returns none. As the
does reverse the list.
it's a request to the list to reverse itself, and the list method does do that. In theory, you could write your own reverse on some other object that doesn't, but
Because the reverse,
reversed is a function that takes any iterable and returns a list. Yep. And remembering that exact difference, it's okay if you forget that. But in general, you got to remember these little details. That's part of what keeps you happy when you're programming. Okay, so there's a list. Access element 0, element 3, the last element, second to last element. Okay, so what's this one going to do? This is going to return, this one returns an element, an element, an element, an element. This one is a slice, and it returns a sub-list. And the sublist is going to be a list of elements that start at index 0 and stop before they get to index 1. So what will this return? Some people said March, and that's not quite right. It's going to return a list of all the elements starting at 0 and ending before 1. So it's not going to return March, it's going to return March, right? It's going to return a sublist, okay? And that's a tricky thing. This one will start at 0 and stop before 2, so it will return March and April in a list, a slice. This one will return the whole list. Start at 0, stop before you get to the -1 element. It will return the whole list except for July. Okay? This one will start at 0 and stop before it gets to element 100. Who thinks it'll give an error? Raise your hand. Who thinks it'll give the whole list? Raise your hand. It'll actually work. So it's completely reasonable to think it might give you an error. Many languages would. In Python, it's like, well, again, as long as you think, the reason I'm using this stop before you get to is that way of thinking about it makes it at least a little bit more comfortable that this would not return an error. Okay? It's a language choice when they design it that this works. And that actually does come in handy sometimes. This returns a list starting as early as you can and stopping as late as you can because we've left off the start and stop. So it returns the whole thing, and those are 3 ways to do the same thing. Okay, so all 3 of those basically make a new list. All of these are making a new list. This is a new list, new list, new list, new list, and these, in this case, all 3 times there, months 2 was bound to a new list where the elements and their order was the same as the old list, but it's a copy of the list. Okay, so the difference is the list stores the ordering of the objects. The objects are shared between them. But those are all immutable objects. They're strings, so you can safely change one and the others won't be changed. Okay? There's a tuple. And there's a copy of the tuple. Oh, no, that's not right. I think I'm wrong. I think I just learned something here. Let me check here. No, I'm right. Okay, yeah. So if you use, so all of these using, start with that tuple. If you use square bracket colon, it returns a slice of the tuple, and it is a tuple type because it's a request to that object, so it returns the same type. And you can do, but you can't do copy. There's no copy attribute. You can't do. There's no copy method on tuple, but there's on list. Some objects have a .copy, some don't. In general, when you are writing, this is to remind me to tell you this, in general, when you're writing a function, try not to think, okay, I'm going to get an argument, which is a list, and I need to do some things with this list. Instead, think more generally. If you can instead write the function as, okay, I've got this list, and I want to do something with it. Let me write a function. But let me write the function so that it takes any iterable and works on it. And don't assume that it's a list. Assume that it could be a list, or a tuple, or a string, or an open file handle, or an open network handle, or anything that can be iterated over, a generator expression, then your code will be more reusable. You'll find you're using it for things you didn't intend it for down the road, which is really nice. Okay, let's get back to that list. There's months 2, which is a copy. They are the same. They are the same what? They're equal. Those 2 lists are equal. When you compare them, they are equal. Are they the same 2 names for the same list? No, because remember, I create a new list when I use the square brackets. So they're different list objects that happen to share the same contents. If I ask month 0 to delete its 0th element, the element at the beginning, March, it will do so, and we can see that March got dropped. But months 2, which is a different list, March is still there. Right? If I take months, which was April, May, June, July, and add months, concatenate these 2 lists together and rebind months, then I get more April, May, June, July. So it created a new list, which was the same as this list plus 1 in front of it as a new list. I said that twice. Okay, can I do this again, or is this going to say doesn't support item assignment? No, I can do this because it's a list. Lists are mutable. There we go. So we fixed March. I can append an element to the list. I can change that element like this, meaning I can add a new object as the last element in the list in place of the object that was there, right? I didn't change the string lowercase August to be a different string. Like there was a string lowercase August and it got thrown away, and I put a new one in its place. Del months 2 is going to return what? No, it's going to do what to the list? The list will then be March, April, June, July, August. Okay, what's this? It's a list of lists. We saw a hint of that when we had the 5, 6, 7, I think, in there. So it's a list with 2 elements, each of which is a list of 3 elements. And if I access the 0th list, I get the list ABC, the list 1, 2, 3. If I access this list and then access its 0th element, I get the 1 back. Okay, so you can use lists of lists to do a 2-dimensional or multidimensional array. Of course, if you're doing anything that's big or you want to be fast, you would use NumPy or Pandas or something like that instead. But occasionally you would do that. And any questions before you take your turn at the exercises? Okay, go ahead. Okay, I'm going to continue here. The first part of this exercise has the most interesting stuff, I think. All right. So remember so we have a list 0, 1, 2. M sub 1 equals is we're basically asking the list to change this link or the piece in here that refers to the object 1 and change it to instead refer to that, the 1020. So this 1020, a list 1020 is going to replace the 1. I hope I did. Okay. That hopefully makes sense. Let's put it back to 0, 1, 2. And now what we're saying is let's replace what? Well, this is saying, so if we just pull this out, if we just access this, we're going to get the sublist that starts at element or index 1, starts at index 1 and stops before it gets to index 2. Well, the part of the list which starts at index 1 and stops before index 2 is just the single element in there. And here we're saying replace that sublist with instead this sublist 1020. So we actually take the 10 and 20 and stick them in as 2 new elements in that list. Okay? One person was asking me, why wouldn't it be something else? This is the way that Python interprets it. You just got to get used to that. There's not really a wrong or right way to think about it. Python chose one way. And so hopefully the way I've been describing the start and stop before will help you at least get the bounds right, which is the most important part.
So it's not inserting it as a sublist.
What's that?
It's not inserting it as a sublist when you do this.
It's that's right. Here it's saying change that element to that sublist. Here it's saying please change that sublist to a different sublist. Yep.
Now, this isn't like unpacking though, right? If we added an extra value in the second, in the 1020, if we added like 30 or like 10 up to 100, it would just replace the 2 values in there with however many values are in that other list?
That's right. This is not like the unpacking earlier. And in fact, it couldn't be. And this example shows that it's not because it's a sublist of 1 element, and we're replacing with a sublist of 2 elements. So if you replaced it with a sublist of 1,000 elements, it would just slide them all over and stick those elements in, as opposed to sticking in one object. Okay. I'll skip that. And these ranges I'm not going to cover. But basically, the same thing you can do with slices, which are what these actually objects that get created as with that syntax are, and range have very similar syntax, and you can play around with those. They're kind of complicated, make you think hard, maybe do some unexpected things, but you can see, basically we're saying, okay, range 101, for example, we're saying start by default at 0 and go, because range you can have multiple arguments as well, which I don't show you here. Oh yes, I do, right there. Right, so start at 0, stop before you get to 101, and create a list from, and that's a range object, and then you can access elements of the range object saying start at the last item, and then count by -10 to get there, as in 10 indexed over, and stop before you get to element at index 1. That language almost always, I think always, saying it that way always will give you the right answer. This argument, the 1? So the first, the slice has up to 3 numbers, and always a colon. So the number before says start with the element at that index. The second one says stop before you get to the element at that index. And the last says instead of increasing by 1, increase, or in this case decrease, by a different amount. Yep, the step, exactly. Okay, yep, that works true. Okay. So, range is an object that you can iterate over. It'll go from 0 up to 7 inclusive. Stop before you get to 8. This is a list comprehension. It has square brackets, same syntax as a list, but inside it's not individual elements. It's sort of like a for loop, which we haven't seen yet in this tutorial. And basically you get to choose the name, E, and then there's a for set of names here, in, and then an expression that gets evaluated. So E for E in range 8, it's just going to iterate over that whole range and give you a list of those elements. You could do this with a for loop. It's a little bit longer. The big advantage to list comprehensions is they are a declaration of what you want as opposed to a declaration of how to make what you want, right? So it's a slightly higher level of abstractions. I want to have a list that's more like a mathematical expression saying, this is what I want. If you did it create with a loop, you'd have to create a for loop and say, well, I want you to loop over and add these things. Well, then you're telling it how to do it. You can put any expression on the left here. So you choose, sorry, I said you choose that name. That's not true. You choose this name. This is the name that you control, the second one. So E for E in range. It's just after the for is where you choose whatever name you want, or multiple names if you're iterating over something that can do tuple unpacking. So here I'm going to take each of those 0 through 7 inclusive and multiply it by 2, and I should get back the list 0 to 4 up to 14. Okay. Or I can add. I can also add an if clause afterwards. If, and then after the if comes any expression, could be quite a long, complicated one, so only give me the even ones. And the expression doesn't have to be, it's any arbitrary expression. So here, the expression is an F string all the way to the end of that quote. So it's going to return me that string evaluated 8 times, with each time through the E being 0, then 1, then 2, all the way up to 7. So I should get back a list of 8 strings that are like that. And you can combine them too. You can combine them if you want, right? So here's the long expression for that, if that, and we get some other. So I said, like, you look back here, that's pretty easy to read. This one, not so much. If I saw that in code you were asking me to review, I'd say just make a for loop. It's easy to read. And that's my general advice is use list comprehensions sparingly. Make sure they have no side effects, like don't put print statements inside or something like that. And usually avoid nested ones. You can actually nest. You can have a list comprehension that says E for E and this for X. You can have them nested multiple times, but they get pretty hard to read after a while. Question?
So what would be the for loop equivalent for the last one?
For the last one?
Because I'm not sure what.
This one I would say for E in range 8 colon. Well, first I would have to create a list. Create an empty list before the for loop. Create the for loop. And then for each element in the for loop, if E percent 2 equals 0, if it's an even number, then I would append this element to the for loop, to the list.
What is that element?
What
Yeah,
is,
it's a bit incomprehensible to me what that element is.
what E is?
No, F.
So this is an F string, F, quote, quote, that's an F string, which means it's an expression like a format string that is evaluated, and it looks for the E in the current namespace, which we created by, say, naming it, by using the name E in the for. Yeah.
I see, okay, thank you.
Yep. Great questions. So here's the name that's going to have each time through a different value. I don't use it at all in the expression, right? So kind of silly. I don't think I would use easier ways to do that, but I'm just pointing out here's exactly what's going on. Help you understand it, hopefully. Here's the months in alphabetical order. A comes before F comes before M. Well, okay, these are months. These are tuples, which include a month number, and a number of days, non-leap years. Okay. If I call sorted on them, it returns me a sorted list, which is the same one, because remember when you compare tuples, it compares April to February, and then it compares 4 to 2, then it compares to 30 to 20. Well, it never got that far because the A and the F and the F and the M, it made the comparison right there. It stopped right there and figured out what order to put them in. I can reverse the sorted. Okay. Element 2 is going to give me the tuple March 3/31. So here's a function. We haven't seen a function yet in this tutorial, but I think most of you probably seen them before. All right, but the way it works is that the def starts a block. You give the name of the function. You give any arguments you want. And then you have the body of the function, which is all the indented stuff, possibly indented further. And then it ends with the first non-indented line, or when you're in the REPL, like we are, the read eval print loop, you have to have a blank line. So this blank line is optional in code you're writing in a file. It's required in the REPL because otherwise it doesn't know whether you're done or not, right? So getIndex is just going to return whatever you pass it, element number 1. So if I call index, hang on, 612, I don't like that name. So this will return February 228, right? 0, 1, 2, it's asking for 1. So getIndex1 is going to return element at index 1 of month sub 2. Well, month sub 2 is March 3/31. Index element 1 is going to be 3, right? And I realized, I just made a note to myself, month is a bad name here because it's anything. It doesn't have to be a month. Let's import the operator module and use its item getter, operator item getter built in, the function in there. So if item getter is a function that you pass it an argument and it returns a function. Who here finds that kind of hard to think about, a function that returns a function? Come on, be honest. Yeah, it is hard to think about. When I started using Python, that was one of the things that for me was hard to think about. It took me a while to get used to it. And decorators were like, because they're functions that return functions, or callables that return functions. So most of them are. Well, yes, most of them are. Unless it's decorating a class, then it's a function that returns a class. Anyway, the point is this is kind of hard to think about, but it's just a simple way to write a function, right? Like this is one way to write a function that returns whatever you pass it, it accesses index element 1 and returns that part of it. This is another way to create the same function object. No, an equivalent function object, right? And the way I give it a name here is I do a def get index. The way I give it a name here is I just say equal. Well, whatever that thing is, whatever that object is that gets returned, which I know is a function object because that's the documentation to item getter says, give it the name and get index 1. And then it just works, same way, okay? This is a common thing you'll see in Python is functions returning functions, functions that take functions as callbacks. Have you seen that before in Python? Give me an example. Oh, no, sorry, that was a trick question and the trick was on me. Sorted is one, but we've seen sorted only with reverse equal true, which is not a function. You can call sort with a key function and a comp function. So that's actually sort and sorted are another one that can take a callback function. So sorry about that, trick on me. So if I call getIndex1 of months sub 1, I'm going to get 2, right? There's month sub 1, that object. I pass it to getIndex1, it's going to return me index 1 of that object. There we go. So do I need to give it a name in order to call it? No. I can just take that and stick it right in place of that. So I take, so again, it's kind of complicated. What's going on here is Python looks up this module name, which was imported, so it's in my namespace. It accesses the object that's got the name item getter, which is a function. I call it with the integer object 1. It returns to me a function, and I call that function passing it that thing, and it gives me back something, okay? So that works just as well. So there was the foreshadowing to what I was trying to get you to say. Here is a function, sorted, that takes a function as an argument. And what it does is, this is one of the ways, there's several ways in Python to take some existing code, which either was by design or by accident, somebody wants to, let me rephrase that. Sorted was designed so that you could change its behavior without having to go in and change the sorted module or the sorted function in a module in Python. You don't have to go edit the sorted function. You can just change its behavior by giving it a key function. So what sort does is it takes the two things coming in, and I don't know if this is exactly what it does, but it says, oh, how long are they? Okay, well, let me start marching through them. Let me compare the first two and see which one's smaller. But it actually doesn't do that. What it does is it says, okay, let me compare the first two to see which one's smaller, but only if they didn't pass me a key function. If they passed me a key function, then I'm going to take those two objects, call the key function on both of them, and get something else back, and I'm going to compare those two objects to see which one is smaller. Okay, that's what's going on here. So so what sorted is going to do with this key callback function is it's going to call this function on those objects, like the March 331, and then in what it gets back, which is the 3, is what it's going to do its comparison and sort the original list, right? So this is going to sort by month month number. So now February comes before March, comes before April. And of course, we don't need to use the getIndex. We can use the operator.itemGetter. So sorted months key equals operator.itemGetter1. That's code that you might see. That kind of code exists a lot in a lot of Python code. And now, even better than before, hopefully, you know how to read it and what it's doing. Okay? And if you want to sort on something else, well, you could do actually this. We could sort on first item getter 01 actually returns I had a note to fix this and I didn't. This is, yeah, let's skip that because it's kind of confusing. Let's just imagine, I'm not going to type it for you, but if you change item getter 1 here to item getter 2, then it would sort by the number of days instead. And let's skip those two. And we'll skip that one as well. Okay, sorry about that. So your turn to do some exercises. Oh, question first.
Yeah, instead of, when you say operator.itemGetter, that's the name of a function that you have, is it possible to use like lambdas? Do you have to assign a name to a function, or can you just?
No, you could use a lambda. Using operator.itemGetter I would use because it's built-in library. People know what it is. If they're familiar with it, they understand it right away. They don't have to parse my lambda. And I'm not going to get my lambda wrong because I won't be using it. Right?
There are lambda functions in Python.
What's that?
I'm asking, are there lambda functions in Python?
Yep, they have limits. You can't do as much as with others. But yeah, I would, yes, a lambda function would work fine in that case. I would recommend use the built-in because it's well known and someone else already got it right. That's all. Okay, other questions? Okay, go ahead and take some time working on the exercises. Okay. Let's look at the exercises here. Split's pretty easy. M for M, just a simple list comprehension. So here, I'm using a nested for n in range 3, for m in Jan, Feb, Mar split. So I get this more complicated thing. And I suggest avoid them, but be aware you can do that if you want to. Enumerate's a kind of cool, is a very useful function, especially in Python. In languages where you always have to remember the index to iterate through things, this is why would you have enumerate. In Python, usually you iterate over iterables without remembering the index, because Python does it for you. But sometimes you actually want to know, well, how far am I? Am I at index 50 when I do this? And enumerate's the easy way to do that. Basically, enumerate, as you can see, it takes an iterable, consumes it, and it returns, in turn, pairs, an iterable of pairs, where the pair is 0a, 1b, 2c. Okay? And you can, of course, change what happens. Like once you've got that n and the c, you can change it there. And by the way, this parenthesis here, these parentheses there are optional, but I think it's a little bit easier to read. Zip is another cool function, which very much like a zipper, but not quite. A zipper, right, interleaves. The zip function doesn't interleave, it does pairs. That's the way it works. And so zip, you can take zip, pass it 2 arguments, and it will pair up the Jan, the 1, the Feb, the 2, the Mar, the 3. If you pass it 3 arguments, it'll give you triples, etc. And then zip returns an object which is iterable, so we hand it off to list, so actually we can see it, what it looks like, and there we get that list. So, what do you think? Will Python give us an error in this case? We've got 3 on the left and 4 on the right, the second argument to zip. And the answer is no. Zip will happily stop when it exhausts the first of its arguments as an iterable. Sort of like the M100. It just, that's fine, I'll stop before I get to 100. If you want it to stop, there's an itertools.zip longest in the itertools module. I don't remember, it may not be the right name, but it will stop when it gets to one of them.
Would it error if they were flipped? So it was like Jan, Feb, Mar, April, and then only 1, 2, 3?
Nope, same. It'll always stop at the shortest one.
Okay.
And again, that is I've used that a lot. It's convenient when, for example, I don't really care. Like I have several of them, and I want to maybe add an index to one of them, and I don't know how many I'm going to have. Well, I'll just put in place of the one I want the index to be. I'll do a range from 0 to max int. It'll only evaluate as many as it needs, and it'll stop when it's done. So that'd be an example of where it's handy to have that functionality. So there's another way to create that list that was created earlier, right? Is you could take, there's the zip of 3 elements. And you can see I'm combining the split, stuff like that. Of course, here's another way to do it. Oh, and here I put in, look at that. There's the range 100, just like I said. And it stops when it gets to the shortest one. And there's something I wanted you to try to solve, and another one, and this one we talked about a little bit about. Key. I'm going to skip most of these. 5 minutes, right? We ended at 4:40? All right, so dictionaries and sense. I'm not going to quite get through the rest of it, which is typical. I put in more content to make sure you can go look at it afterwards. Dictionaries are really important, helpful data type in Python. A list is actually a mapping, is one way to think about it. Like, remember math, Venn diagram, dots in it, the arrows that map from A to B. That's what I mean by a mapping. And a list maps from integer 0 to the first element, integer 1 to the second element at index 1, integer 2, etc. And so here's an example of, right? So if I take Jan, Feb, Mar, well I'd really like Jan to be index element 1. So I put a none in front of it, or I could use that in Python 3 or 5 or greater using that syntax. Now I've got 0, 1, 2, 3, which is convenient for me because 1, 2, 3 are the month numbers as I think about them, right? So now I can map it. I can say, well, give me, take an int, turn it into a month, and I get back Jan is 1. Number 2 is Jan. Sorry, number 1 is Jan, number 2 is Feb. A dictionary is a one-to-one mapping from anything, almost. It's got to be hashable. I'm not going to cover that today. to any other thing. So instead of assuming the index value or the key value of 0, 1, 2, 3, et cetera, here I have to explicitly state it. And I can use integers if I want. So here I'm saying map 1 to Jan, 2 to Feb, 3 to Mar. And then I can just say into month 1, 2, 3, and it works. So a dictionary is more powerful in terms of there are more things you can do with it. It's also much, it's very fast for searching and finding things in it. Okay, I can do that too. Instead of explicitly doing the mapping, I can do a dictionary comprehension, I think is what it's called. So it sort of looks like a list comprehension, but it kind of looks like a dictionary with a curly brace and a colon, with the key and the value, and these are variables that are iterated over, that change through that iteration. So that's another way to do it. And then I can just access it, right? Month to int. So here I'm doing month to int instead of int to month, right? And so I've got January is month 1, et cetera. April is 4? No, it's not there. Okay, let's add it. So this is how you access elements of a dictionary. Use the square brackets just like a list, and you pass it the key, which doesn't have to just be an int. It has to be whatever key you've defined the dictionary to have. And you can see it now has an April over there on the end. In for dictionaries is asking the question, is this key in the dictionary? Is there a key value pair in the dictionary with this key? Here's how you would delete an element from the dictionary. You give it the key and it'll delete that. You can't ever have two duplicate keys, so you don't have to worry about how to figure out which one to remove. There's only going to ever be one key feb in a dictionary. That's one of the constraints. Just like months, you can't have two elements at index 1. There's only one element there. Okay. Is February in there? Not anymore. Okay. Do a couple things here. How to use dictionaries. Dictionaries are one of the data structures in Python that if you haven't had them in languages you've used before, you will find yourself not reaching for them until you get to know them, and then you'll find yourself reaching for them all the time. So for example, if you want to know how many letters there are in, what are the letters in Mississippi, here would be a way to do it. So when I'm done, letters is going to be a dictionary with key M. We'll have 1. What's that? No, no. I'm looking for what letters are in Mississippi, right? So S is going to be set to 1 4 times. No, we're not counting letters. We're just saying what are the letters in Mississippi, okay? Or I can just look at the keys and I get back this data structure that I can iterate over that shows me those are the letters. Here's another way to do the same thing using a dict comprehension. There is a collections module in the standard library that has a default dict. You can pass it a function and it will add elements to a dictionary on the fly. So earlier, with a regular dictionary, this would give me a key error. With a default dict, it doesn't. It gives me a 0 because it said, oh, I can't find it. So I'll call this function to figure out what to put in its place, added the key value pair, and now it's in there. So this one, I could do what you were getting at, which is let's count them, right? And I get the letter count, right? So it added letters as needed and incremented them. So the first time it saw the M, it stuck in, well, that's a bad example. First time it's, because I already did it up here. First time it saw the I, it stuck it in as 0 and then incremented it, made it 1. The next time it pulled it out as a 1, incremented it to 2, put it back in, etc. And then you can look at how many of the letters are in there. There's also a collections counter that will do this for you, and a bunch of other things. And if you only care about the keys, like we did in the first example, well, there's a simpler way to do it. There's a set built-in type, and you can also create sets with a set literal like that. Looks kind of like a dictionary with curly braces, but has no colons because you only care about the keys. And you can do various operations. Mississippi, you're all familiar with. The Assiniboine, it's in my backyard. It's one of the 2 rivers that runs through Winnipeg. Here's another way to do the same thing, but set operations are pretty handy at line 687. And lots of set operations. Okay. So I can put almost anything in a dictionary key, but not quite everything. And I won't be able to explain why, but it's basically because they have to be hashable. Because if they weren't, I'm about to explain why. Then when you change the key, you can change the contents of a list. Then when it goes to hash it and look it up fast, it would find it in the wrong place, or not find it because it would look in the wrong place. Okay. So what I did not get to show you was an example with dictionaries, which is kind of cool. Blocks and for loops, iterators and generators, and a little bit about imports, calling functions, etc. So we got through a fair chunk of the tutorial, and I hope it was helpful. Please fill out the evaluation forms. Give me feedback afterwards. I'm happy for that as well. And hope you enjoy using Python.